Last time we solved, all right, to calculate the reactance of the capacitor and also the current flowing in the circuit. But before we found the current flowing in the circuit, we were able to find the impedance of the circuit. So today we're going to look at how to calculate the voltage across the capacitor. It's very simple, my dear. The next thing, we're going to calculate the impedance and voltage across an inductor of this value. That is this. But we may not waste our time calculating the impedance because we have already calculated the overall impedance, right? Good. So what we're going to do is to calculate the voltage across the inductor. Two things, voltage across the capacitor and the voltage across the inductor. And we're done. And very soon I'll sign out again. So let's go. Voltage across the capacitor is given as I and then XC because we've already found this. We've already found XC. We already know the value, the current flowing in the circuit. So the current flowing in the circuit is very simple. 2.87 times 10 raised to the power minus 5. Okay? It's like I'm squeezing things up here. Let's see. I want to repeat this. Okay? Let's see how we are going to do that. So the voltage, capacitive voltage is given as I and then XC. That's capacitive voltage, right? So what we need to do is to substitute accordingly. By the time we do that, we have something like this. The current is already given as 2.87 times 10 raised to the power minus 5. That's the current flowing times the value of the reactance of the capacitor, which is 636.62 ohms. Okay? I'm looking for Chuck, which is 636.62 ohms. If we multiply this, if we use this to multiply this, we're going to have 0.018. So we have 0.018 volts. Okay? This is the value of the voltage, okay, flowing through or across the capacitor. That's the current, the voltage across the capacitor. Okay? That's solved. Then let's see what happens next. We have found this. We need to find the voltage across the inductor. I take chalk again. I will continue to take chalk until I'm done with what I'm doing. So the voltage across the inductor, that is VL, is given as current flowing in the circuit and then the inductive reactance XL. Very simple. So what do? We have current is already given as 2.87 times 10 raised to the power minus 5. Okay? And then the inductive reactance is given as 47.13. 47.13. Good. So what do? That's what they want us to do. They want us to calculate this. Alright? So you can do that. VN. Okay? So let's see. I want to leave this side for you. Come on. Tax yourself a bit. Just use your calculator. Punch this. Multiply by this. Whatever it gives you, put it here. Put it here, question mark. You can see the two question marks. It's left for you. Okay? And then cross-check. The next thing you're going to do for me is to cross-check all these steps that I've taken to find all these answers. Cross-check if they are correct. If there is any disagreement somewhere, put it in the comment section. I will be notified and I'll solve it and address that disagreement, okay? Because I want us to agree. You are my returning subscribers. You are my new subscribers. I want you to belong to this community of learners, community of teachers that teach to make impact and make a difference in the lives of our students. See you in my next class. I'm signing out once again. It's solved. I've solved this. I've found out, so I am moving out. I'm leaving you now. Come on.